In this video, we'll see that how to draw a clipping circuit in Multisim. Before I go to the Multisim software to draw the circuit, let us understand a basic theory of that. So basically, clipping circuits are of two types. One is positive clipping, one is negative clipping, and based on that, there is parallel clipping circuit also and series clipping circuit also. So what is a clipper circuit? What does it say? So as a name is saying, it clips out some of the portion of the input. Okay. So depending on how the circuit is there, so some of the portion, let's say this is the input, then some of the portion will be clipped out in the output and remaining this part only will be in the input. So this is how the clipper circuit works. Here the figure also you can see that there is a input is there, which is a full wave cycle is there, full wave AC signal is there, and in the output some portion of the positive cycle is being clipped out, but it is not zero actually here. So 0.7 volt amount of voltage still there for the positive cycle, and the negative cycle fully it is available. So here we are just clipping out a portion of the input, so that is important to understand here. And based on the diode configuration, how we are keeping the diode in the in the circuit, that will be decided that it is a positive diode clipping or it is a negative diode clipping. So this is a example of a parallel clipper with negative clipping. So in the negative clipping, you can see that the some of the portion of the negative part is clipped out, but there is some part in the negative cycle also. That means completely it doesn't make it to zero. So there is still some amount of voltage or current available in the negative cycle, but with a clipped amount. The clip means what? It is a label there. Fine. So now let us understand how does this work. With a simple explanation I will tell. So in the positive half cycle, what happens? You see the diode is now forward bias, but the diode property is that it will be forward bias after the potential barrier is being broken, and generally for the germanium diode or silicon diode it is 0.7 volt. So after 0.7 volt only the diode will be forward bias, and till the input signal reaches the 0.7 volt we will get the output. And then what will happen when it crosses the 0.7 volt, the output will be 0. That means always there is a potential of 0.7 volt appear, and if I measure the voltage as a parallel here, then we will get that the output is at 0.7 volt for positive cycle, and in the negative cycle it becomes your reverse bias. In that case what will happen, no current will flow through the diode, and all the voltage or current signal available in the input, that is the same thing will be available in the output as well. That is why clipping circuit works. Now let us go to multisim and let us try to create the same circuit here. We will see how does this work. So first I need a AC source here. So for that I will go to power sources, I will go to AC power, and here I will take the AC signal. Then I need a ground also. I'll just take the ground from here. What else I need? I need a diode again. I'll go to this group, and from the group I'll select diodes. So diode virtual also you can take, this will work. But practically we'll take a diode which is used in hardware and lab also, that is IN4007, and you can see this is from the Motorola company, it is doing that, it's a package. So I'll just take the diode, and one more thing I need, that is called as your resistor. So I'll go to this basic, under the basic I'll find the resistor there. I'll take a standard 1 kilo ohm resistor. So a resistor I'll place it here. Fine, now all the circuit requirements have been done. So let us connect the circuit. So one side I'll connect to the resistor, and this diode will be connected in parallel. So what I'll do, I'll just rotate the diode in this downward direction, and I'll connect the resistor end to the diode, and the diode end will be connected back to the source where the ground is also connected. Remember, in multisim ground is an important factor. Towards the input side always connect the ground. Now the circuit is complete. So here you see 120 volt RMS is there. So let us reduce the voltage so that we can see the output properly. I'll take here, let's say 5 volt I'll take. 5 volt and 50 hertz. So let me take it 50 hertz here also. Then what I need to see the output voltage. So that's why I'll take a oscilloscope here. It's a 2-channel oscilloscope, but we can use for 1 channel or we can use for 2 channel, that depends on it. Now the channel A, I will connect to the output which is parallel to the diode. So I will connect it here, and the channel B I will connect to the input so that I can compare that what is happening and how it is clipping out a part. So the input is connected here, and the other part also I will connect to this point. So now I have connected that to input, and for convenience what I can take, I will change the color of the signal of this line, then the signal color will also be changed. So that is important to visualize something. So I will just change it to blue. Fine, now my circuit is complete. Let us simulate it and see that what is happening there. So if I simulate, I will double click on the oscilloscope and we can see still a output is available now. Now if I make it to single, yeah, so if I make it to single, now you can see that it is not pulsating and you can visualize properly. So here the see red line you see here. So let me increase the voltage per division, will decrease the voltage per division so that it will be visible clearly. Okay, let it the channel B is the input. So channel A is the output I have taken. So output you see the negative cycle is there as it is, but in the positive cycle you see the red line is at a clipped area. That means whatever input we have shown in the that output. So here you can see the same thing we are getting here. Now to properly visualize, I will make both the voltage division same here. So I can increase the size of this oscilloscope also like this, so that it will be better visible now. Okay, now because in the negative cycle the output and the input are following exactly same, that's why the red line is actually coinciding with the blue line where it is not visible. But still if I change the y position of that, see if I increase the y position by 0.2 voltage, then I can see. But to compare, we should always take both the signals at the same level. So I will take the middle as the axis. Now this white horizontal line is your zero line. Above 0.7 up to 0.7 volt I am getting the value, and then in the downside I am getting all the input voltage. So let me do this division up to 1 volt. Let me write 0.7 volt here. So if I write 0.7, so it doesn't take the input from keyboard. If I further increase 500 millivolt, so you can see one division is now 500 millivolt, and after that some amount is there, so that can be taken as 200 millivolt. So total 700 millivolt or 0.7 volt we are taking. So that's how you can create a simple clipper circuit using diode, a parallel clipper circuit and also a positive clipper circuit using diode. So thank you. In the next video, we will see negative clipper circuit and some other variations of the clipper circuit as well. Thank you.